This question is from Jun04, paper 4, question number 5. The topic is connected objects. In this question, there is a new concept that the force exerted on the pulley by the string, force exerted by the force exerted on the string by the pulley has a magnitude of 4 under root 2 newtons. We will discuss this important concept in this question. Particle P and Q are attached to opposite ends of a light inextensible string. P is at rest on the rough horizontal table. The table is rough. The string passes over a small smooth pulley which is fixed at the edge of the table. Q hangs vertically below the pulley. The force exerted on the string by the pulley has a magnitude of 4 under root 2 Newton. Now the force exerted on the string by the pulley on the string by the pulley is equal to the force exerted by the string on the pulley. देखें दोनों forces, the force exerted by the string on the pulley is this one is the force from this side, and from this side the string is exerting the force on the pulley, and the pulley will exert the same force on the strings. अगर ये सेम नहीं होंगी तो फिर क्या होगा, पुली को या तो इस डायरेक्शन में मूव करना चाहिए अगर स्ट्रिंग्स की फोर्स ज्यादा है, और अगर पुली की फोर्स ज्यादा है तो पुली को इस डायरेक्शन में मूव करना चाहिए. But the pulley is at rest. It means the force exerted by the strings on the pulley is equal to the force exerted by the pulley on the string, and which is equal to 4 under root 2 Newton. It is given. Now, the string is exerting the force on the pulley. This string in this direction and this string in this direction. और ये टेंशन है वायर के अंदर जो फोर्स एग्जर्ट कर रही है पुली के ऊपर. The tension in the string is exerting a force on the pulley from two sides. One is the horizontal, from the horizontal table, and the other one is from the vertical string. Now that pulley smooth, आपको पता है कि टेंशन ऑलवेज एक्ट्स अवे फ्रॉम द ऑब्जेक्ट, तो पुली के हिसाब से राइट साइड की तरफ एक्ट करेगी और डाउनवर्ड एक्ट करेगी. And the tension in the two strings is same because the pulley is smooth. Now we will add these two tensions with the help of vector addition. One force is in the right direction towards right side and having the magnitude T. The other force is in the downward direction and having the magnitude T. Now, according to the law of addition of vectors, we will join the tail of one vector with the head of the second vector, first vector. Now, we will join this vector with the tail of this vector. This force is T, this force is T, this one is the resultant, this one is the tension, the two tensions exerted on the pulley, and has a magnitude of 4 under root 2 Newton. So this angle is 90 degree. With the help of Pythagoras, t square plus t square is equal to 4 under root 2 whole square. 2t square is equal to 32, t square is equal to 16, t is equal to 4. So the tension in the string is 4 Newton. Now we have T is equal to 4 Newton. State the mass of Q. Now the two particles are in, the system is in equilibrium. The tension on the particle Q is this, and this one is the weight of the particle Q. Now T should be equal to mg. T is 4 newtons. We have just calculated. M is equal to 0.4 kg. So the mass of Q is 0.4 kg. Now part number 2. In part number 2, given that P is on the point of slipping, that is, there is a limiting equilibrium. Find the mass, find its mass. Now we want to find out the mass of the particle P. We will draw the forces on the particle P. Now P has the tension with respect to P. Tension is towards the left side. The table is rough, so friction will act towards the right side, weight downwards or upwards. Now equating the forces along the horizontal plane, T is equal to mu r. Because the particle is on the point of slipping, the weight of Q is 0.4 newtons. The tension T is also 4 Newton. T is equal to 4 newtons. Now 4 is equal to mu is 0.8 and R is mg. M is equal to 0.5 kg is the weight of P. Now, part number 3. Find the tension in the string while the particles are in motion. Part number 3. A particle of mass 0.1 kg is now attached to the particle Q. Now, the mass of the particle Q is 0.4 kg. 0.1 kg is attached to the particle Q. Now the mass of the particle Q is 0.5. That is 5 Newton force will act downwards. Tension in the string is T. Now for part number 3, For particle Q, 10, T is equal to 5. For part number 3, pa- uh, particle Q will move downwards. So force in the direction of motion is 5 minus tension is equal to m into A. For particle P, force in the direction of motion is T. Force opposite is mu r is equal to 0.5 into A. T minus mu is 0.8 and r is mg. Mf the particle mass of the particle P is 0.5 mg, which is the normal reaction, is equal to 0.5 A. Solving the two equations, 5 minus T is equal to T minus 0.8 into 0.5 into 10. 2T is equal to 5 minus 5 plus 4. So T is equal to 4.5 newtons. This one is the answer to part number 3. Now we will attempt question from November 10, 4th paper 4-3, question number 3. This question is of the same type as we have attempted earlier. A small smooth pulley is fixed at the highest point A of a cross section ABC of a triangular prism. Angle ABC is 90 and BCA is 30. The prism is fixed with the face containing BC in contact with the horizontal surface. The particles P and Q are attached to the opposite ends of a light inextensible string which passes over the pulley. The particles are in equilibrium with P hanging vertically below the pulley and Q is in contact with AC. The resistance force, the resultant force exerted on the pulley by the string is 3 under root 3 Newton. Show that the tension in the string is 3 Newton. Now, this string is exerting the force on this pulley A, one from this direction and one from this direction. This force is T, this force is T. As the pulley is smooth, so the string in both parts of tension in both parts of the string is same. Now we will find out this tension T. Both the tensions T and T exert a combined force of 3 under root 3 Newton on this pulley. One force is this, in this direction, and the other force is in this direction. Now we will place one force at the head of the second one. This one is the first tension. We will place the tail of second vector at the head of first vector. This angle is 60 degree because this one is 30. This angle is 60. This angle is 60. This angle is 120. The resultant of the two forces is joining the tail of the first with the head of the last. This one is the resultant of two forces. This force is also T. Now we will apply cosine rule to find out the resultant. The resultant is this one is 3 under root 3 given. So by applying the cosine rule, three under root 3 square is equal to t square plus t square minus 2 into t into cos 120. Cos 120 is 1 by 2, negative 1 by 2, 9 into 3, t square plus t square plus t square, 3t square is equal to 9 into 3, t is equal to 3. So the part number 1, for part number 1, we have the tension in the string equal to 3 newtons. We will add the two tensions at the pulley with the help of vector method, and we can find out the resultant force with the help of Pythagoras if the triangle is right angle, or cosine rule if the triangle is not a right angle. Now the part number 2. The coefficient of friction between the Q and the prism is 0.75. Q and the prism is 0.75. Given that Q is in limiting equilibrium and on the point of moving upwards, so the friction will act downwards. Find its mass. Now the tension in the string is 3 newtons. With respect to P, tension is in this direction. With respect to Q, tension is in this direction. The particle has the tendency to move up the plane, so friction will act down the plane. This one is the weight of Q. These are the components of weight. The component along the plane is mg sine 30. And this component is mg cos 30. This one is the normal reaction R. Now part number 2. We will start working for part number 2. Tension we have already calculated. That is 3 newtons. Now we will consider the forces on the particle Q. First of all, equate the forces along the plane. T is equal to mg sine 30 plus mu r. And now we will equate the forces perpendicular to the plane. R is equal to mg cos 30. T is 3. Sin 30 is 1 by 2. Mu is 0.75 and R is m into 10 into cos 30 is 0.866. 3 is equal to 5m plus 6.495m. From this equation, m is equal to 3 over 11.495 and is equal to 0.261 kg. This one is the answer of the part 2. Thank you.